Hi there, in this tutorial I'm going to take a look at how we can map and analyse crime data. Although you can also apply this technique to any point data set where you might want to examine hot and cold spots and identify patterns in the frequency of occurrence. So I'm getting my data from data.police.uk, which, as you can probably guess, is the UK police data download site. But obviously you can use your own crime data set or any other point data set that you have available and want to work with. So I'm going to go here and click on their downloads link, and I'm going to select June 2019 because it seems that not every constabulary has their July data up at the time of me making this. And we can select any and all forces. I'm just going to select Greater Manchester Police for simplicity. We can also choose whether we want the data about crimes, outcomes, stop and search. I'm just going to download crime data and then click generate file. So this should download data showing the occurrence of all crimes reported in June 2019 to Greater Manchester Constabulary. So we can see this produces a folder which in turn contains a CSV file. So that's a comma separated file that you could open in Excel or any other spreadsheet software. In fact, we'll take a quick look just so we can see what the data looks like. And we can see we have a crime ID, the month where it's reported, but importantly for mapping purposes we also have longitude and latitude, which will allow us to map the occurrence, a descriptive term for the location. These are references to the UK's Office for National Statistics statistical areas if we wanted to map them at an area level. And we also have the crime type, and it does have some information even though I didn't tick the outcomes box on the latest outcome. So this will allow us to pinpoint the location of the crime and also look at different types of crime and compare patterns between different crime types. So I'm actually going to copy this file from the zip file and I'm going to put it into my data folder. So I'm going to make a new folder called crime just to keep things nice and tidy, and paste my CSV file in there. And now to get started on the mapping I'm going to fire up QGIS. So QGIS, as you may well know, is a free and open source GIS package. If you don't know anything about QGIS, then please check out some of my earlier tutorials that cover all the basics of downloading, setting up and getting started with QGIS. So I've dragged in an OpenStreetMap from the XYZ tiles layer just to give us some context, a bit of a base map. And I can now go into my data folder which I've favorited. And actually, because this is a CSV file, we could just drag it straight in. It doesn't always work as well as we'd hope. Sometimes it picks up columns as the wrong type of data. So I'm actually going to use the data source manager here, pick delimited text, and go to my data, crime, and add the CSV file this way. And if we look at geometry definition, we can see that we've got point coordinates, it picked up longitude and latitude, and our CRS in this case, because it is latitude and longitude as we saw when we opened up the CSV file, we're going to select WGS 84, which is essentially latitude and longitude coordinates. And we can then click add, and we can see it now adds these points onto the map. Now, one issue that I have with this is latitude, longitude is great, plots the points fine, but later on when we want to produce hotspots from this, and we have to set some parameters linked to the point spacing, it actually uses whatever units our layer are in. I don't know about you, but I find it pretty hard to think in degrees when I'm setting distances. I'd much rather have it in meters, yards, whatever you work in. So what I'm actually going to do next is to resave this as a new layer, but convert it into a different coordinate system that works in meters. So I'm going to right click on my point layer here, go to export, save features as. I'm actually going to leave it in the QGIS GeoPackage format because it's quite a nice, neat format. And I'm going to change my CRS, in my case, to British National Grid because I'm working in the UK. But you can obviously identify the appropriate coordinate system for whatever area you're looking at if you're working in a different part of the world. File name. So I'm going to go C data back to my crime file, and I'm going to call this crime OSGB. That's for Ordnance Survey Great Britain, which is the projection that I'm using for my data set. And now I can click OK, and we now have what appears to be an identical data set, but is now in British National Grid rather than latitude and longitude coordinates. So I'm going to remove the original layer, and just for consistency I'm actually going to go down to the bottom corner here and change the projection it's being displayed in, and also make that British National Grid as well. We can see that the shape of the map changes slightly as it distorts the grid into British National Grid rather than the projection it was using previously. Okay, so now we've got a mass of points covering the Greater Manchester area, but that doesn't particularly tell us anything. It's pretty confusing. Fortunately, one of the great features of QGIS is that it allows us to create hotspot maps without really having to do much work at all. So if we right click on our crime layer, go into Properties, Symbology, and actually drop down here and change it to heat map. I'm just going to click Apply straight away. And instantly we've got a heat map for our data. Now it's not particularly useful, partly because kind of what we're seeing is pretty broad, and also because the map is covering everything underneath it. And we can deal with that in a couple of ways. We could change, expand the layer rendering menu down here, drag our layer opacity down to make it slightly see-through, and we can now start to pick up some details underneath. But what I actually like to do, so firstly I'm going to change the colour ramp that I'm using. Let's try magma. So this helps really highlight the hotspots. We can see now much more easily that the centre of Manchester kind of stands out as a hotspot compared to the surrounding towns with smaller hotspots focused on some of the suburban areas. Oldham, Rochdale, Bury, pretty much any kind of built up urban centre appears to be a bit of a hotspot. But having this area greyed out still isn't particularly great. So what we can do is actually edit colour ramp and make colour 1 transparent. And what this should do is actually mean the very lowest values that are shown dark grey at the moment will become transparent. There we go. So we can now differentiate between low values and essentially no crime. And we can see actually even within the area it covers there are some gaps, particularly within the rural areas where there's not many people about. Now the other thing that we can play with is the radius. So when we're creating hotspots, it's entirely up to us how it kind of calculates those hotspots, how smooth or detailed our hotspot map is. Now what I prefer to do, by default, it's doing it by screen units of millimetres. So actually I'm going to click OK on that for a second, just so we can zoom in and out a bit and see how this looks. So if I were to zoom now towards the centre of Manchester, we can see that it actually changes to set the points that are within our current view, and we can see that almost kind of single points at this level, individual crimes are showing up, but we still have a hotspot around the centre of the city. And that's great if we just want to navigate round and explore. On the other hand, if we want to print things out, produce figures to go in reports, we might not want that display to change as we zoom in and out. We might want to keep kind of consistent hotspots no matter what we do in terms of our display on the screen. So if we want to do that, we can go back into properties, change our radius units to map units, and this is why I changed our projection earlier from latitude longitude, because our map units are now meters. So rather than having to think in degrees, which as I said is pretty difficult for most people, we can now think in meters. So I'm going to set a radius, and we can play around with this to see how it looks. So I'm going to start off with a radius of 100 meters. So we can see that's actually finer than it was using already. So this picks up quite fine detailed hotspots. And if I zoom in and out now, you can see because I've set it to map units, actually that doesn't change as I zoom my display in and out. So actually at the level we're working, maybe 100 meters is a little bit too fine. So let's try changing that to 250 meters. Okay, so that seems to work a little bit better. It certainly highlights the hotspot in Manchester city centre, and we can just about make out some smaller hotspots in surrounding areas. If we were to reduce that even more, let's say 500 meters, it starts to look a little bit more like it did earlier on, and actually some of these hotspots in the suburbs once again become a little bit clearer. Also, if you're feeling that it looks a bit grainy on the screen, we can change the rendering quality down here. It will take a little bit longer to draw, but oh, sorry, I dragged it to fastest, so now it's gone very pixelated. If I drag it up to best, it will take longer to draw, but should look much smoother on the screen. So I'm going to move it back down to the middle for now, just to get that balance between speed and quality. So in a nutshell, that's how we can create some basic hotspot maps. But obviously this is just showing us all crimes. It may be that one of the things we want to do is actually to look at how hotspots differ between different types of crime. So if we want to do that, then we can go to Source, the Source tab in our layer properties, and go to this Query Builder option down here. And what this actually allows us to do is to select subsets of our point layer. So we could do a selection query, export it as a new data set, but then we end up with lots of different data sets. It can be useful depending on what we want to do. But if we're just doing this for display purposes, one thing we could do is just create a quick query here. So in my case, I'm going to do crime type equals, and we can get it to list by clicking either sample or all over here the different options that we have, different values we have within our crime type field. So I'm going to start off by saying antisocial behaviour, the top one. So if I click OK now and then do apply here, we can see that actually in this case we have very little change, possibly because antisocial behaviour makes up quite a high number of the crime values that we're looking at. So let's try something else that might look a bit more different. So if I delete antisocial behaviour, reset that first, so delete that. Okay, you can see it redraws. So try again, crime type equals, and let's go for vehicle crime. And hopefully you saw as soon as I clicked OK there, it did jump slightly. So what we're highlighting now are the areas that have vehicle crime. And what you might notice if you were looking closely, is we now have a bit more gap right around the city centre, and that's because actually most people don't park right in the city centre. It's probably pedestrianised, but we now have a series of hotspots a little bit further out, which are probably identifying the main parking areas just on the outskirts of the city centre. People parking over in Salford to get the train or the metro into the city centre, and some of the other areas on the outskirts of Manchester. One of the slight issues that we have with displaying our hotspots this way is we don't actually have a scale. So QGIS is kind of automatically generating, sort of looking at the data we have, identifying the greatest density and the lowest density for our points, but it doesn't actually give us values, which makes it quite difficult to compare different maps and data sets. It may well be that there's a lot fewer reports of vehicle crime than there were of antisocial behaviour, but because QGIS is automatically scaling those, it's quite difficult for us to pick up. So we may have to look at using some other tools if we want to be able to get that legend, and we can do that using the processing toolbox. And if we open up our processing toolbox and start typing hotspot or heat map, we'll see that one of the tools we have is this heat map kernel density estimation. Now there are various ways of calculating hotspots. Kernel density estimation is one of the most commonly used. So we can open up this tool, and the settings are quite similar to the ones we were using in our layer settings to just display hotspots on the fly. So we can select our point layer. If we have a selection, we can use selected features only. Once again, we can set our radius, and you can see that's set to meters. So I'm going to change that to 250, the same as our display on the screen. We can set our pixel size, which is obviously going to influence the quality of or the detail in the output layer. I'm actually going to reduce that slightly to, let's say, 5 meters, just to speed things up a little bit. If we want, we can actually set some more advanced parameters, but I'm not going to worry about those for the moment. I'm just going to stick with the defaults, which normally give us quite a nice heat map. And obviously we can set the output. So go into my crime folder again, and you can see this is going to produce actually a raster layer. So at this stage we're kind of converting from our original point layer into a raster hotspot layer. And we're still set at the moment to vehicle crime. So I'm actually going to call my output layer vehicle crime and click run. And we can see that if I turn off our original layer, we now have this new layer produced, and this now does give us values for the density. So we can see that in this case the maximum density, and our radius was 250 meters, is about 9.3 vehicle crimes per 250 meter radius. So if I want to compare this, we can now go back into properties, go back to source, query builder. So let's clear that query, and if I turn that back on, we should see we now have slightly larger hotspots showing underneath, and I can run this kernel density estimation tool again. I'll use the same settings, same output resolution, and call this one all crime. And we can see it's now taking a little bit longer because there's a lot more points to look at when we're considering all crimes rather than just vehicle crimes. So we'll give that a few seconds. And there we go. We now have our heat map for all crimes. So if I just change the colour scheme for our vehicle crime heat map, just so that we can distinguish between the two. And we can now see the difference between the two layers. If we wanted to, we could once again add some transparency. So we can kind of see one through the other, and we can see, okay, this is a little bit backwards. We might want to flip our colour ramp around here, invert, so that red indicates hotspots rather than blue. And we can now see how actually all crime, we have a hotspot around here, but for vehicle crime specifically, it's spread a bit further out around the edge of the city centre. And with that, we can now play around with the settings. We can select different types of crime, try different radiuses, and that should give you everything you need to really compare and identify the hotspots within different types of crime, or, as I said earlier, any other type of point data where you want to identify clusters. One final little display trick that I quite like, you might notice under our symbology options, so I changed it to single band pseudo colour to allow me to pick a colour ramp. Another option that can work quite well for displaying heat map data is actually Hillshade. So we'd normally use Hillshade for displaying elevation to pick up the shape of the landscape, but because we essentially have high and low points, we can kind of represent these in pseudo 3D using the Hillshade option. Now with vehicle crime, it's quite low, or the maximum value is quite low, so we may need to exaggerate that slightly to pick up the peaks. For our all crime data, you may have noticed our maximum density is much higher, 266.7 compared to 9 and a bit for vehicle crime data. So if we were to represent that as a hillshade, we should see immediately that the peaks appear much higher, particularly around the centre of Manchester there. And if we were to add a bit of transparency to that, we can now visualise underneath and pick up the peaks in our data, overlaying on the centre of Manchester. And with a bit of playing around, as I said, experimenting with the most appropriate radius setting for your particular data, we can get some really quite nice visual displays, picking out high and low points, or areas of high and low density within our data. So hopefully that's been useful. If you did enjoy that, please remember to like and subscribe to the channel, and check out some of our other videos. Thank you.